Welcome to today's ArXiv Computer Science Digest for May 26, 2026. We received 945 new computer science papers today across 60 subfields. Let's dive into the top picks. Trend 1 of 10, Probing LLM Semantics and Bias. Analyzing large language models' semantic understanding and identifying their inherent biases through various probing techniques. This cluster covers 81 papers. Representative work includes MATCHA, matching text via contrastive semantic alignment, semantic gradients interactions in SSD, a case study in racial identity and hate speech, and when does demographic information help? Data and modeling regimes for perspective-aware hate speech detection. Trend 2 of 10, autonomous AI agent development and alignment. Developing and aligning autonomous AI agents to ensure their capabilities and actions are beneficial and safe. This cluster covers 119 papers. Representative work includes MUSE-Autoskill, self-evolving agents via skill creation, memory, management, and evaluation, natural language query to configuration for retrieval agents, and Genesis, harnessing AI agents for autonomous 6G RAN synthesis, research, and testing. Trend 3 of 10, algorithmic theory and applications. This trend explores the theoretical foundations, design, analysis, and diverse applications of algorithms across various computational and real-world problems. This cluster covers 86 papers. Representative work includes algorithmic monocultures in hiring, compute optimal tokenization, and 2 ASP/Q programs with weak constraints, complexity, and efficient implementation. Trend 4 of 10, efficient multimodal generative media models. Efficiently generating and manipulating diverse media content using multimodal generative models. This cluster covers 77 papers. Representative work includes from scores to Gibbs correctors, accelerating uniform rate discrete diffusion models towards controllable image generation through representation conditioned diffusion models, and pair, pruning, and adaptive routing for efficient video generation. Trend 5 of 10, AI system security and auditing. This trend focuses on developing methods and tools for securing, auditing, and enhancing the trustworthiness and robustness of AI systems. This cluster covers 71 papers. Representative work includes RSD, a local triangulation audit primitive for learned vector blocks, risk-averse alert prioritization for IDS using subnormal Gaussian fuzzy models, and detectability and diversity. Improved canary crafting for privacy auditing in one run. Trend 6 of 10, foundational neural network methods. Explores core methodologies, architectures, and optimization techniques that advance the fundamental capabilities and understanding of neural networks. This cluster covers 120 papers. Representative work includes Merit, learning disentangled music representations for audio similarity, incremental Gauss-Newton descent for machine learning, and PNSER, physics-informed neural networks for PDEs on curved surfaces. Trend 7 of 10, vision language models and robotics. Vision language models enhance robotic perception, reasoning, and interaction across diverse applications and industrial settings. This cluster covers 94 papers. Representative work includes Spatial Bench. Is your spatial foundation model an all-round player? Locate anything. Fast and high-quality vision language grounding with parallel box decoding. And SOL, R1, video language reasoning as the sole reward for on-robot reinforcement learning. Trend 8 of 10, LLM efficiency, reasoning, and security. Advancing LLM performance, deployment, and safety through innovations in efficiency, reasoning, and security. This cluster covers 150 papers. Representative work includes mobile MOE, scaling on-device mixture of experts, guiding LLM post-training data engineering with model internals from sparse autoencoders, and the AI cognitive Trojan horse, how large language models may bypass human epistemic vigilance. Trend 9 of 10, 3D graphics and scene understanding. Developing computational methods for interpreting, manipulating, and rendering 3D environments and understanding complex scene dynamics. This cluster covers 67 papers. Representative work includes G3T-UP, gravity-aligned coordinate frames simplify point map processing, feed-forward 3D editing learns from semantic part transformation, and megakernel versus wavefront GPU path tracing. Trend 10 of 10, advanced optimization and game theory. Explores sophisticated methods in optimization and strategic decision-making across various complex systems. This cluster covers 80 papers. Representative work includes stochastic non-smooth convex optimization with unbounded gradients, shortest path problem with subnormal Gaussian fuzzy costs, and probabilistic smoothing with ratio monotone transforms for global optimization. Up next, our first paper out of 10, SJ, Self-Improving AI with Harness and Weight Updates by Pranay Heber and Vignesh Bhaskaran from Hexo Labs. This paper was selected because it addresses the most fundamental and long-term pressing problem in AI, enabling AI to autonomously improve itself, which represents a transformative leap in the field's development and directly tackles the human bottleneck in. Let's break down its key contributions. Contribution 1, SIA, Unified Self-Improvement. SJ, a self-improving AI system, was introduced, enabling a language model agent to update both the harness and weights of a task-specific agent. A feedback agent autonomously modifies the agent's scaffold, tools, prompts, search procedure, and its underlying model weights based on task feedback. This novel approach unifies two previously disjoint research lines in AI self-improvement, addressing the human bottleneck in AI development by enabling autonomous system refinement. Contribution 2, SIA's performance gains. SIA achieved substantial performance improvements across three diverse domains: Chinese legal charge classification, GPU kernel optimization, and single-cell RNA denoising. The system's ability to combine harness updates for agentic behavior with weight updates for domain intuition allowed it to surpass methods relying solely on scaffold iteration. SIA delivered a 56.6% gain on law bench, a 91.9% runtime reduction on GPU kernels, and a 502% improvement on denoising over the initial baseline. Up next, our second paper out of 10, Detecting is Not Resolving: The Monitoring Control Gap in Retrieval-Augmented LLMs by Zhiyu and Meng Han from Binjiang Institute of Zhejiang University. This paper was selected because it identifies a fundamental and widely overlooked flaw in retrieval-augmented LLMs, revealing that detecting epistemic conflict does not guarantee its safe resolution, which is critical for the reliability and trustworthiness. Let's break down its key contributions. Contribution 1, Monitoring Control Gap Discovery. Models exhibit a monitoring control gap, readily acknowledging contradictory evidence, but failing to constrain their final recommendations. This was demonstrated using a multi-turn document accumulation protocol across 4 model families, 1.5B, 32B parameters, and over 50,000 turn-level evaluations. This gap means single-turn diagnostics systematically overestimate RAG safety, and contradiction acknowledgement is uncorrelated with safe resolution, making current RAG systems untrustworthy in high-stake settings. Contribution 2, Flawed RAG Evaluation Protocols. Current RAG evaluation protocols are fundamentally flawed, incorrectly assuming single-turn robustness predicts robustness when evidence accumulates across turns. The authors show this assumption is incorrect by demonstrating that models detect contradictions but fail to bind action in multi-turn scenarios. This leads to a systematic overestimation of RAG safety, creating a false sense of security for systems deployed in critical applications like medical guidance. Contribution 3, Action Selection as Failure Locus. The action selection computational step is identified as the most plausible locus of the monitoring control gap deficit in RAG LLMs. This was determined through converging mechanism evidence, including hidden state probing, attention analysis, and a response strategy taxonomy. Danger-relevant information is internally represented and receives enhanced attention, yet it fails to constrain output behavior, indicating a need to focus interventions on the final generation stage. Contribution 4, Gap widens with scale, no universal fix. The monitoring control gap in the Qwen 2.5 family widens with scale, 1.5B32B, and no universal prompt fix exists to resolve it. This was observed across 4 model families and over 50,000 turn-level evaluations using a multi-turn document accumulation protocol. This refutes the hypothesis that larger models naturally close the gap and highlights the inadequacy of prompt engineering for addressing this fundamental safety issue. Up next, our third paper out of 10, LEC, Linear Expectation Constraints for Selection Condition Risk Control in Selective Prediction and Routing Systems by Ziyuan Wang and Kaidi Su from University of Electronic Science and Technology of China. This paper was selected because it introduces a principled framework for selection condition risk control, offering statistical guarantees for accepted predictions from foundation models, which directly addresses the critical and pressing problem of model unreliability. Let's break down its key contributions. Contribution 1, LEC Framework for Risk Control. A principled framework named LEC, Linear Expectation Constraints, is introduced for selection condition risk control in selective prediction. It reframes selective prediction as a decision problem governed by a linear expectation constraint over selection and error indicators, directly controlling the marginal error probability conditioned on selection. This formulation ensures that an accepted prediction has an error probability no larger than a user-specified risk level, addressing the lack of statistical guarantees in foundation models. Contribution 2. Finite sample calibration. A finite sample sufficient condition is derived for LEC to compute a risk-constrained, retention-maximizing threshold for single-model selective prediction. This condition relies solely on a held-out calibration set and assumes exchangeability to determine when to accept or abstain from predictions. It provides a practical and statistically sound method for calibrating selective prediction systems, maximizing accepted predictions while adhering to a specified risk level. Contribution 3. Two-model routing extension. LEC is extended to manage two-model routing systems, enabling intelligent delegation of inputs between models. When a primary model's uncertainty exceeds its calibrated threshold, the input is delegated to a subsequent model, maintaining system-level selection-conditioned error control. This extension allows for more robust and efficient deployment of foundation models in complex pipelines, ensuring risk guarantees even with multiple models. Contribution 4. Empirical validation and retention. LEC is empirically validated across closed-ended and open-ended question answering, QA, and vision question answering, VQA, tasks. Experiments demonstrate that LEC consistently maintains the prescribed risk level in accepted predictions. The framework substantially improves sample retention compared to baselines, showcasing its practical effectiveness in real-world applications. Up next, our fourth paper out of 10. Give me BF16 or give me death? Accuracy Performance Trade-Offs in LLM Quantization by Eldar Kurtisi and Dan Alistar from Red Hat AI. This paper provides the most comprehensive empirical study to date on LLM quantization, offering critical, actionable insights into the accuracy performance trade-offs that are essential for the practical and efficient deployment of large language models. Let's break down its key contributions. Contribution 1. FP8 quantization is lossless. FP8, W8A8. FP quantization was found to be effectively lossless across all model scales of the Llama 3.1 family. This was discovered through a comprehensive empirical study involving over 500,000 evaluations across academic benchmarks and real-world tasks. This finding provides strong evidence that FP8 quantization can be adopted without significant accuracy concerns, enabling efficient LLM inference. Contribution 2. INT8 quantization low degradation. Well-tuned INT8, W8A8, INT quantization achieved a surprisingly low 1 to 3% accuracy degradation on the Llama 3.1 model family. The study evaluated this format using a broad automated evaluation suite covering academic benchmarks like Open LLM Leaderboard V1/V2 and real-world generative tasks. This demonstrates that INT8 quantization can offer substantial computational efficiency with minimal impact on model performance, making it a viable option for many applications. Contribution 3. INT4 weight-only competitiveness. INT4 weight-only, W4A16. INT quantization proved to be more competitive than expected, rivaling the performance of 8-bit quantization. This was determined by evaluating its accuracy across the Llama 3.1 model family using a diverse set of academic and real-world benchmarks. The unexpected strength of W4A16 INT suggests that even lower bit width quantization can achieve good performance, potentially leading to greater memory and speed benefits. Contribution 4. Optimal quantization deployment guidelines. The study provided clear deployment recommendations for optimal quantization formats based on different LLM inference setups. This was achieved by analyzing inference performance using the VLLM framework across 3 GPU architectures, A6000, A100, H100, and 7 deployment scenarios. W4A16 is recommended as most cost-efficient for synchronous setups, while W8A8 dominates in asynchronous continuous batching, offering practical, data-driven guidelines for deploying quantized LLMs at scale. Up next, our fifth paper out of 10, the attribution blind spot, detecting when language models rely on memory rather than retrieve context by Zhiyu and Meng Han from Binjiang Institute of Zhejiang University. This paper was selected because it identifies a critical attribution blind spot in retrieval-augmented generation (RAG) systems, revealing that models can produce context-consistent outputs from parametric memory rather than retrieved evidence. Let's break down its key contributions. Contribution 1. Attribution blind spot identified. The paper identifies and names the attribution blind spot, a critical failure mode where retrieval-augmented generation (RAG) outputs appear context-grounded but originate from the model's parametric memory. This blind spot occurs when retrieved documents overlap with pre-training data, allowing the model to produce identical surface text from either external context or internal memory, making the true computational pathway indistinguishable. This phenomenon undermines the core promise of RAG to ground outputs in external evidence, making it impossible to verify source attribution for high-stakes deployments and impacting system reliability. Contribution 2. Computational Reality Monitoring (CRM). The paper introduces computational reality monitoring (CRM), a novel method to detect when language models rely on parametric memory rather than retrieved context. CRM operationalizes a principle from cognitive science by comparing the model's internal representations with and without context, revealing membership-conditioned representational divergence that output-level monitors miss. CRM provides a necessary substrate for source attribution by revealing diagnostic signals in internal representations that are invisible at the output level, laying a foundation for internally aware AI systems. Contribution 3. Empirical Validation of CRM. The study empirically validates CRM's ability to detect the attribution blind spot across 9 model variants from 3 model families. The representational divergence detected by CRM concentrates in architecture-specific layer patterns and is further supported by block-level noise intervention, demonstrating a consistent internal signature of memory use. CRM generalizes across tasks and datasets, proving the blind spot is measurable and partially addressable, though it collapses on domain-confounded benchmarks, indicating areas for further refinement. Up next, our 6th paper out of 10, Hardware-Software Co-Design of Scalable, Energy-Efficient Analog Recurrent Computations by Arthur Fionn and Guillaume Drian from University of Liège. This paper was selected because it proposes a novel hardware-software co-design approach that overcomes a long-standing barrier in analog computing, enabling energy-efficient recurrent neural networks crucial for ubiquitous, always-on AI. Let's break down its key contributions. Contribution 1. Analog RNN with noise immunity. The paper demonstrates the first analog recurrent neural network with structural noise immunity. This is achieved by implementing bistable memory recurrent units, BMRUs, in an ultra-low power current mode analog circuit where discrete outputs suppress noise. This overcomes the long-standing challenge of noise accumulation in analog recurrent dynamics, previously considered impractical for always-on AI applications. Contribution 2. Novel BMRU analog circuit design. A novel current mode analog implementation of bistable memory recurrent units, BMRUs, is designed from first principles. The BMRUs are reformulated for first quadrant operation with fixed thresholds, establishing a one-to-one correspondence between learned parameters and circuit elements. This design preserves expressivity and trainability while enabling a direct hardware mapping for ultra-low power and noise-robust operation. Contribution 3. Quantified noise suppression mechanism. The developed analog BMRU circuit achieves significant noise suppression through its inherent design. Its discrete valued outputs and hysteretic dynamics actively suppress analog noise by at least 20-fold at each cell boundary. This mechanism effectively breaks the noise accumulation barrier, enabling practical and robust analog recurrence for complex tasks. Contribution 4. High-fidelity co-design and power scaling. A hardware-software co-design approach is validated, where the software model serves as a high-fidelity simulator for the physical hardware. Transistor-level simulations in 180 nanometers CMOS show near-perfect agreement between software predictions and circuit-level behavior, enabling large-scale analyses. This fidelity reveals that the power cost of recurrence scales linearly with state dimension, leading to sub-microwatt inference for end-to-end keyword spotting. Up next, our 7th paper out of 10, Where Code Meets Natural Language. Taxonomy-driven information flow analysis for LLM integrated applications by Zaheo Su and Yuekong Lee from University of New South Wales. This paper was selected because it identifies a fundamental and critical gap in program analysis for applications integrating large language models, proposing a novel taxonomy-driven approach to bridge the opaque boundary between code and natural. Let's break down its key contributions. Contribution 1. NL/PL boundary taxonomy. The paper introduces the first information flow method to bridge the NL/PL boundary in LLM integrated applications, defining a 24-label taxonomy. This taxonomy categorizes placeholder output pairs based on information preservation level, lexically preserved to blocked, and output modality, natural language, structured, executable artifact. The taxonomy's reliability was validated with Cohen's kappa equals 0.82 and achieved 0.01% unclassifiable pairs across 9,083 real-world Python pairs, demonstrating robust and comprehensive coverage. Contribution 2. Enhanced taint propagation. A two-stage taint propagation pipeline was developed, achieving an F1 score of 0.923 on 353 expert annotated pairs. The pipeline combines taxonomy-based filtering to identify potential flows with subsequent LLM verification to confirm taint propagation across the NL/PL boundary. This method significantly improves taint analysis for LLM integrated applications, with its effectiveness further confirmed by cross-language validation on 6 real-world OpenClaw prompt injection cases. Contribution 3. Efficient backward slicing. Taxonomy-informed backward slicing was demonstrated to reduce slice size in files containing non-propagating placeholders. The slicing algorithm leverages the taxonomy's labels, particularly those indicating blocked information flow, to prune irrelevant program parts that do not contribute to the output. This approach achieved a mean reduction of 15% in slice size, providing a more efficient and focused analysis for LLM integrated applications. Contribution 4. Key non-propagation labels. Per-label analysis identified 4 blocked labels within the taxonomy that account for nearly all non-propagating cases. This discovery was made by systematically evaluating which of the 24 taxonomy labels correspond to blocked information flow across the 9,083 analyzed placeholder output pairs. These specific labels provide actionable filtering criteria for tool builders, enabling the development of more precise and efficient program analysis tools for LLM integrated systems. Up next, our 8th paper out of 10, Foundations of a Time-Consistent Counterfactual Actuarial Runtime for Autonomous AI Agents by Hao-Su and Chen from National Chengchi University. This paper was selected because it proposes a foundational and highly novel actuarial runtime layer for autonomous AI agents, directly addressing the critical and pressing problem of accountability and liability for AI actions with a paradigm shifting. Let's break down its key contributions. Contribution 1. Well-defined counterfactual toll. A well-defined counterfactual toll is established for autonomous AI agent actions. This toll is computed against a contractually fixed safe default and a chosen continuation policy, explicitly acknowledging its non-uniqueness. This provides a foundational mechanism for pre-action risk pricing for every side effect-bearing action, replacing traditional post-hoc liability with a dynamic, runtime assessment. Contribution 2. No-splitting property for actions. A no-splitting property is established within an underwriting boundary for AI agent actions. This property telescopes path-decomposed actions into a boundary potential, ensuring that breaking down an action does not reduce its overall risk assessment. This property is crucial for gaming resistance, preventing agents from manipulating the system by splitting actions to reduce their perceived risk toll. Contribution 3. Irreversible authority premium. The paper defines an irreversible authority premium, quantifying the cost of granting an AI agent irreversible authority. This premium is split into a strictly positive action level component and an if and only if characterization of the set level robust capital increase required. This provides a mathematical basis for understanding and budgeting the capital requirements associated with granting autonomous agents decision-making power, ensuring robust financial backing. Contribution 4. Conservative runtime gating theorem. A conservative runtime gating theorem is presented, enabling real-time control over AI agent actions. This theorem translates high-probability toll envelopes into an executed action budget guarantee, ensuring that actions stay within predefined risk limits. This allows for pre-execution budgeting and gating of actions, blocking or escalating those that exceed the allocated risk budget, thereby enhancing safety and control. Up next, our 9th paper out of 10. Vectors are not neutral. Sensitive information inference from exported LLM representations in summarization by Weixin Liu and Zhuming Xiong from Vanderbilt University. This paper was selected because it uncovers a critical and often overlooked privacy vulnerability in LLM systems, demonstrating that sensitive information can be inferred from derived vector representations even when source data is restricted, which is highly relevant to pressing Let's break down its key contributions. Contribution 1. Residual vector risk. Discovered that compact vector representations exported from LLM summarization systems pose a residual information disclosure risk in high-stakes applications like clinical discharge summary generation using EHR-recorded race. The study audited two specific artifacts, the final prompt token hidden state and the mean-pooled prompt representation, demonstrating that sensitive information can be inferred even when source documents are access-restricted. This highlights a significant privacy vulnerability in common LLM workflows, where derived data can still reveal private attributes, necessitating careful consideration of data protection for vector artifacts. Contribution 2. Artifact-specific leakage. Proved that reducing sensitive label recoverability from one exported vector artifact does not necessarily reduce recoverability from another. The research audited both final prompt token hidden states and mean-pooled prompt representations, demonstrating that privacy properties are not uniformly distributed across different types of LLM internal representations. This finding establishes that privacy auditing and mitigation strategies must be artifact-specific, preventing a false sense of security if only one type of representation is protected. Contribution 3. Surface low RA mitigation. Introduced surface low RA, an exported vector-targeted parameter-efficient fine-tuning method designed to reduce sensitive information recoverability from LLM vectors. Surface low RA employs a gradient reversal discriminator attached to a designated exported vector to specifically target and minimize the leakage of sensitive attributes during the fine-tuning process. Under a balanced 5-way probing protocol, surface low RA successfully reduced EHR-recorded race recoverability from the targeted final token artifact toward chance while preserving summarization utility, offering a practical mitigation technique. Up next, our 10th paper out of 10, Function-Valued Causal Influence in Nonlinear Time Series by Valentina V. Kiskova and Michael Koppich from Lucy Family Institute for Data and Society, University of Notre Dame. This paper was selected because it introduces a novel conceptual framework for understanding causal influence in nonlinear time series, moving beyond scalar summaries to function-valued representations, which significantly advances the interpretability and rigor of causal discovery in complex systems. Let's break down its key contributions. Contribution 1. Formalizing function-valued causal influence. The paper formalizes function-valued causal influence for additive, contribution-decomposable architectures in nonlinear time series. It argues that scalar causal scores are a severe information bottleneck, conflating between-state variation with within-state residual noise. This formalization addresses the fundamental mismatch between nonlinear models' learned representations and their scalar summaries, enhancing interpretability in complex systems. Contribution 2. Framework for causal response functions. A practical framework is introduced for estimating causal response functions directly from trained models, specifically using neural additive vector autoregression, NAVAR. This framework is based on individual conditional expectation, IC, allowing for the direct extraction of state-dependent functional effects from the model's internal workings. It provides a concrete method to move beyond scalar summaries, enabling researchers to analyze the full state-dependent effects learned by complex nonlinear models. Contribution 3. Qualitative functional behavior discovery. Controlled synthetic experiments demonstrate that causal edges with indistinguishable scalar scores can exhibit qualitatively different functional behaviors. These behaviors include monotonic, threshold, saturating, and sign-changing effects, which are revealed by analyzing the full function-valued influence rather than just a single score. This empirically validates that scalar causal scores are an information bottleneck, obscuring critical nonlinear dynamics and leading to misinterpretations of causal relationships. Contribution 4. Real-world causal structure discovery. An applied case study on democratic development showcases the utility of function-valued causal analysis. The analysis reveals regime-specific and asymmetric causal structure that is systematically missed by traditional score-centric approaches. This demonstrates the real-world significance of the proposed method, providing deeper insights into complex social systems and improving the interpretability of causal models. That's all for today's ArXiv Computer Science Daily. If you found this helpful, please like, leave a comment, and subscribe for daily paper summaries. See you tomorrow.